Good afternoon, everybody, and welcome to this session. I'm Emil Svanberg, and with me I have Daniel Olsson. We are here today to talk about 5G Edge and how it relates to activities we have ongoing in the Swedish innovation ecosystem. First of all, we work at RISE. RISE is a Swedish state-owned research institute. We exist all over Sweden, and we do all kinds of things in all kinds of areas of technology. But of course, Daniel and myself, we work at the computer science department, where we are about 100 staff in total, engineers and scientists mostly. And we also exist all over Sweden. But we're today here at the ICE Test and Demo Center, which is located at the very north of Sweden, shown on the map to the right there. So we're at about 65 degrees north. We're about to have midnight sun, or close to at least, in a couple of weeks. So days are long this time of year. Of course, if you come in December, they're not so long. We don't have a lot of light. As a research institute and as a computer science department, we engage in experimental and applied research. We like to build things and test them. And we sometimes jokingly say that we do everything from ground to cloud. So we have data center systems research that goes into energy aspects of data systems. How do we build and operate them in an environmentally friendly way, and all the way up to various forms of applied AI. These are some quick facts about the test and demo facility that we are located at. As I said, it's in Luleå, northern Sweden. This is a very busy slide showing lots of facts, but we have a data center of reasonable size, more than 2,000 physical servers, about 250 kilowatts of IT, lots of RAM, lots of storage, lots and lots of cores. We also have a fairly large GPU cluster. A couple of years ago, I think it was probably the largest GPU cluster in Scandinavia. I think others have caught up since then. And this is a place for experiments and research in data centers from the systems all the way up to applied AI. And at this test and demo facility, we also have various test rigs, experimental setups for various things, including edge computing. And before we move on, I'm just going to say that we will move outside and have a look at a couple of our experiments, both outside, and then we'll go inside the actual data center and have a look at some of our examples there.
Okay, so now we are outside of the test and demo facility. We're looking at two containers, which is an edge experiment. So this is like an edge-sized data center. The lower container is full of IT equipment. We're not going to show you that, it's just standard racks. But the top container is much more interesting. So part of a European project, We District, we're powering this data center using fuel cells. So fuel cells are powered by gas. We wanted to do it on hydrogen, but there were all kinds of complications, so we're actually using biogas to do that. So we're using biogas to power the data center, and as if that's not enough, we're also reusing the waste heat generated by the IT equipment here to feed back into the what's it called? The district heating system. So that's an example of an exciting test setup we have here at ICE Test and Demo. Okay, welcome inside. We're now inside of the ICE Test and Demo facility, and we are in the edge testbed corner. So here we have all kinds of edge-related technology tests ongoing. So if we look at this on this side, we have an example of an edge data center. This one contains two full racks of IT equipment. But the interesting thing is how it is connected to cooling. So behind here, there's a storage tank, water. It takes care of the excess heat. There is a heat exchanger here, and this all connects to various ways of reusing this heat. I'm no expert in these areas, but it goes to district heating or whatnot. And over here we have an edge data center that's connected to a microgrid. So there are batteries here, and there are solar cells on the roof, and there's a microgrid controller. So this is an experiment where we can operate with the local grid and connect it to the main grid and see how that exchange is happening. Okay, so walk with me. All right, so on my right hand side here we have 2 data center modules. This is where most of our IT equipment is located, and this is where the experimental data center is actually operated. Behind me we have what is an open compute experimental testbed. I think we have close to 500 OCP servers in there. And the blue boxes there, it's a climate chamber, so we can simulate all types of climates in the world, unless the very coldest. But of course we have that outside, so there's no need for simulation. And if we look here, we have an example of a liquid cooling test bed. So Daniel, let's see if we can see inside. Yeah, so this is just an example. Servers are submerged into liquid, some kind of oil for cooling. That's yet another example of edge and data center test beds that we work with here at ICE.
All right, so we're back after having looked at those edge computing test and experimental setups. Let's focus even more closely on 5G edge computing as a focus area. In Sweden, there is a newly inaugurated national innovation program that's called Advanced Digitalization. The program was founded by some of our largest industry companies, including ABB, Ericsson, Saab, and it's funded by Vinnova, our national agency for innovation. So this is a large program on digitalization, and it has identified 5G edge as one of the core areas to focus on. And we are involved in a couple of projects. First of all, we have an infrastructure project, which is building an infrastructure that will later be used and shared by other projects in the same program. So we're building a pilot of what we hope to be the Swedish cloud of clouds infrastructure. And then there are a range of applied projects within the program as well, and we're currently involved in one of them, and that is 5G edge innovations for mining. So that's all about applications for autonomous mining, where we of course use 5G and edge technology. What else do we do in 5G edge? Well, close by, near our facilities here, we have the Luleå University of Technology, and at their campus they have a 5G network. And we have been allowed into that network and placed an edge cluster there. So we're hosting, together with the university, a 5G edge test bed. And this slide shows an overview of activities we have ongoing there. So it is, the very core part of this message is that it was this first standalone 5G network in Sweden. And we have placed an edge cluster, like a small data center, right at the local breakout point to be able to come as close as possible to the end user and the clients on the 5G access with the compute power. So we're building various experiments there to highlight and demonstrate the capabilities of this 5G network together with edge computing. And as shown on this slide to the right, we have been working on some mining examples here. So we're using this test bed as like a staging environment for the experiments that we will later bring into a real mining environment. And here is Daniel, our lead architect for the data center as well as our edge systems. And I will now invite him to talk more about the software stack and the technical aspects of our platform.
Thank you, Emil. Let's see. Here is a picture of our cloud and edge architecture. It's a simple one. And if we start from the top, we have ICE Connect, that is our self-service portal. It's something that we have developed ourselves. And using this portal, you can access resources at the cloud and at the different edge sites that we have. And if we look closer to on the edge site here and the stack, we can see OpenNebula, and we are using OpenNebula here to virtualize the hardware. And on top, On top of OpenNebula, we run a Kubernetes cluster that is connected to Ice Connect. And using Ice Connect, you can connect to all of the edge nodes and as well the cloud services. And using this common point of contact, you can deploy applications spanning the cloud and edge or multiple edge clusters that are distributed in Sweden in this case. So let's go forward. So why did we choose OpenNebula? We wanted an hypervisor that is open source, of course, and had some features that we were after. And we chose OpenNebula because of these points that I have here. And the most important is that it's a multi-tenant by design. And something that I really like about OpenNebula is the possibility to create specific views for tenants, these role-based views. And it also had built-in cost management that was a surprise to me. This is something we normally implement by ourselves. It's scalable and highly configurable. Like if we compare to OpenStack that we are running as well, you do most of the configuration when you deploy OpenStack, and afterwards it's really hard to do specific configurations. But in OpenNebula, you kind of all of these or many features or configurations options are exposed in the GUI and the API. And the best part here is this, that you have a single point of contact for multiple clusters. And it suits us perfectly when we have our data center and we have all these edge nodes deployed in Sweden. And I thought that I bring up some constructive feedback as well when I started to use OpenNebula and play around with it. And we have the front end deployed centrally in the data center. And OpenNebula needs routed access to all the hosts. And normally the edge sites are in a private network somewhere behind the firewall and so on. So you can't access it like OpenNebula would like to do. So to solve this, we created VPN tunnels to all the edge sites. So this becomes a little bit of a hassle. But if we compare to another management solution that we use for managing our Kubernetes installations, in that case, the site itself, or the host, or the Kubernetes installation registers to Rancher that runs in the cloud. And this type of solution would be really nice in the case of these private network installations. And something we noticed was that when we had a power failure, the VM was not rebooted, the VM running on host. And this is something we would expect that you can at least configure that it will do. And of course, because we are running many AI applications and so on, we deploy GPUs on the hosts, but there is no native GPU support. So you have like GPUs as a resource in OpenNebula currently. So what we did was to use the PCI pass-through feature. And when we did that, we noticed that some features was disabled because this was a custom configuration, like snapshots, for instance. And to be able to do a better integration to Ice Connect, and we would like to see support for OpenID or SAML authentication. So what plans do we have for OpenNebula? So we plan to expose OpenNebula, the front end and APIs in our self-service portal. And we are preparing for this. We have already the OpenNebula Sunstone installed, and we have the VPN access to the edge, but we are not currently providing this access to our customers that want to do experiments. But this is what we are going to do in the future.
All right, thank you, Daniel. So that takes us to the end of our presentation. And before we round off, I would just like to highlight a few key takeaways from this. Is that we're using OpenNebula to power our edge test beds that are distributed across Sweden in numerous projects. So we have one at the university campus site. We have one running at the paper mill test bed. We're taking it underground in a mining environment. In one of these projects that I mentioned, and we're hoping to take it to an airport application as well in the near term. So we will be bringing OpenNebula installations to lots of exciting places in the years to come. Thank you, and please ask lots of questions.
Thank you.